Alright, well, how y'all doing? My name's Cameron Nixon, and welcome back to the discussion. Today is March 2nd of 2020. The reason I know that is because it's the 8th anniversary of a pretty prolific tornado event in the Ohio River Valley region. We had the Henryville, Indiana EF4, pretty long track tornado, and we had a widespread outbreak of supercells and tornadoes over this general vicinity. So, what have we got today? This has been a pretty wonky forecast leading up to this point. We've got this strong digging upper level trough, kind of nosing in through the Baja region. And ahead of that, you're naturally going to get height rises. And we've also got this kind of northerly branch trough kind of moseying down into this vicinity too. So what that's going to do as I step forward, it really pinches together those height lines and creates for this really enhanced speed max. Got over 170 knots through this region. So this is probably just a little bit above the tropopause, but it's still a pretty good testament to how fast our winds are in the upper levels. So what really keyed me in about today, a few days in advance, is that, you know, we had the moisture ahead of the system, the low-level moisture, and we had this really strong speed max, and this general area really likes its upper-level speed maxes because I think what's going on is that in the plains, you have these north-south oriented dry lines, and when you have your really widespread discrete events, you only need a southwest to northeast oriented jet to kind of get those supercells to move off that line. Whereas in this region, all we're left with is this really sheared out southwest northeast oriented cold front. So we really need a strong component of wind going orthogonal to that cold front, in this case west or even past that, to get these supercells to roll off that line. And when you do have that, you can get some pretty prolific events. The March 2nd, 2012 event was a prime example of this. But what none of us had was confidence in the area of initiation, if anything would initiate, or how it would, when it would, etc. So I can speed over to what is happening right now. This is the current visible satellite. And we do have attempts at initiation over this region, which has actually been pretty sunny throughout most of the day. We've got even into the low 70s over up here, 50s, but 60, low 60s nosing in. So what is the forcing? What has actually transpired to make this a feasible severe event? Is this very subtle surface low that we got working its way kind of into this area. And the key word, I guess, still is subtlety. It's a really, really weak low, really diffuse warm front up here. So really not a lot to draw you in to a potential severe threat. However, this is probably going to prove to be pretty good or supportive for supercells and discrete supercells because we have this diffuse initiation mechanism. And that's one thing that worries me, is that there's really not many things that key me into an upscale growth mode of today. So if you do get a supercell or two to pop off this, how long is it going to last? Well, there's two things we need to answer. First off, how wide is the moist sector here? And second off, what is boundary layer? What is the boundary layer going to do as we reach nightfall, which is currently in progress right now? So contrary to initial model runs that I saw kind of earlier this week, this warm sector has expanded a little bit. I don't know what that's a product of right now. I'm not going to go into that. But we actually do have a pretty wide moist sector reaching, halfway through Tennessee. And as the system moves forward, it'll probably advect a little bit forward as well. So the other issue is boundary layer destabilization, which would hinder an otherwise more significant threat. And the one thing that could suggest a little bit more stabilization than usual for this region is you do have some pretty, I guess I don't want to say high, but like you have some substantial temp dew spreads for this area for this time of year. So I'm wondering if that will allow this 70 right here to kind of cool off a little bit more than usual. So there's a pretty definitive chance that our boundary layer cools off and we decouple, and we don't get half the hazards that are possible today. And as you can see, there's a thick stratus deck kind of ahead of where these storms are initiating from. But again, theme of the day is discrete nature. Here's one, and a couple other little bubblies around here. But there's not really anything that's screaming out this is going to grow upscale. So these supercells here, when they become them, will really have this unimpeded access to whatever environment sets up ahead of it, which I'll guys talk about now. So what ingredients do we have that would key us in for supercell growth? We have this really strong upper level jet, as we talked about earlier. I worked us down to 500 millibars, and we still have 50 to 70 knots, kind of overspreading this general area. And when I see these really powerhouse jets, I usually think pretty strong supercell dynamics, because it better disperses the shear throughout a really deep layer. And I'll pull up a photograph later. But what really intrigued me is that kind of initially our lower mid flow is generally pretty weak. We have about 31 knots, generally around 30 knots in this area. But we have this advertised kind of impulse. I'm not exactly sure where this comes from. So anyone more synoptically inclined, feel free to chime in, because I want to know. It does look like it forms due to some really subtle shortwave that forms as the interaction between this oncoming trough and this upper level trough. But I can't be too sure. But what that does, I've seen that in RAP and NAM forecasts, is kind of jet this little impulse through the region, giving it some pretty hefty mid-level flow. So what this I'm thinking is going to do is turn a mainly hail risk into something that's a little bit more conducive for tornadoes. And I will show that via photographs later. A50 flow is the same deal. You have this kind of generally ramping up flow in this general vicinity, which could help enlarge the low-level curvature and yield a tornado threat as well as hail. So I guess I could pull up a couple soundings. So here is the Cape forecast. I'll do that first. This is about initiation time. Surface base Cape, we have about 1,500 worth, probably a little bit less for mixed layer. But what's really interesting is we have this pretty low top. Our EL is sitting at about 9 kilometers, but we do have pretty thick Cape through this region. So usually this kind of Cape thickness would lead me to believe that there is a pretty powerful updraft potential, but this EL slipping down below 9 kilometers or so could tame some of the storms we have. Maybe our hail won't be as large as what could be possible, or tornadoes as intense. But this is just plucked right around the initiation point at about this time. We've got a pretty long photograph. What's really weird is everywhere above 6 kilometers, we have an amazing speed shear. We have almost 100 knots of storm relative flow. I looked at this earlier. It goes off the map, or off the chart. And I really don't have much of a precedent for this in a tornadic environment, frankly, and I don't know what exactly that's going to do. I know these photographs are very good for hail production, because it places, especially if your storm motion is a little bit faster, which it could be with these strong winds, than what's predicted by bunkers. But it places a lot of strong storm relative flow through a deep layer, through this 0 to 1 kilometer layer. And that proves to be usually pretty good for hail growth, as I'm learning right now. And But you also have the threat that, well, you have pretty streamwise vorticity. Your critical angle is 81. This generally makes for some pretty efficient tornado production with supercells. I have read research that kind of looks at this really strong upper level flow and its impact on the strong near surface inflow. And this could make it such that storms are more efficient at producing downdrafts that can disrupt this process. But I guess I would rather stay on the safe than sorry side and say that this is a tornadic hodograph. You have substantial SRH, and this general hodograph shape is pretty decent at maintaining tornadoes for longer periods of time. And our 3 cape, our low level cape, is pretty good throughout this whole time. As we'll go forward, we'll assess the boundary layer destabilization's impact on this value. I'm not, again, that's usually a wild card for these kind of events. So it's no wonder that the latest SPC outlook has this area, or they debated putting the enhanced in this area because of boundary layer destabilization. Because if we get this to cool off just enough, you'll just have these hefty hailers riding over a stable boundary layer, and that's not conducive for tornadoes whatsoever. So I will scoot forward a couple hours. This is probably when you'll have a couple to a few supercells maintained, especially after what we have seen right now in current satellite. So you get that little inversion right here, and that's going to play a big role in whether or not we're going to get anything but hail. But I guess it's my opinion at this point that with our pretty fair amount of cape above this level, especially near the ground, we still have 104.3 cape. I'm not exactly sure if this layer is deep enough or if this inversion is strong enough. You can see our hodographs enlarge even more. This is actually looking very favorable for hail growth, and as well as tornadoes at this point. And can go on to, I'm just going to cruise over to 5Z because I've seen some pretty interesting scenarios with this. And your boundary layer does not stabilize very much, and I've seen this with NAM as well. And I'm not a model connoisseur, so please, someone attack me on this. But I'm not seeing immediate obvious signal for storms to be interacting with a stable boundary layer. So really large level hodographs. This gets a little bit wonky, a little bit more favorable for like a cyclic type tornado. I've been going really back and forth because frankly, this hodograph is rare for this kind of event, and it's really tripping me up. But we do have this general increase in low level cape, and I'm wondering, now that I think about it, if that's due to some mid-level cooling, because so this would tend to suggest that we get rid of this worm sector in the mid-levels and start scooching toward this upper level trough. I'm learning as we go, but I'm really wondering what is causing this kind of signal for a delayed destabilization in some of these models. You would think that with generally weak, if any, moisture advection going on, that we would destabilize. But if we were to pump out something like this around the midnight hour in west central Tennessee into Kentucky, it's an interesting scenario, and I know all things are being accounted for today. It's just I don't know how to convey the uncertainty I have with this. So this is really this is a fun event to forecast, because it's like I'm confident that I'm unconfident about my forecast, and that's a good way to leave this off. So if you enjoyed this, definitely leave a comment to continue the discussion. And I'm looking, I don't like saying this, I'm looking forward to seeing what happens tonight, because this is something that definitely bends my brain a little bit. So thanks for watching. Have a good one.